Hello, everyone. Welcome back to Introduction to Logic. This week, we're going to be leaving categorical logic behind and instead looking at truth functional logic. You can also call this modern logic. Okay, so what is truth functional logic, modern logic, etc.? Well, in truth functional logic, we're going to end up translating sentences in natural language like English into sentences composed of symbols, right? These symbols are either going to stand in for bits of statements, things that can be true or false, or they're going to stand in for ways in which those statements connect to one another. So, first, we need to get clear on what the point of modern logic, what the point of TFL is. Well, again, it's all about validity. So it's about establishing some kind of structure by which we can judge the success of arguments, right? So in TFL, we're only concerned about structural validity. You might call it validity in virtue of form, right? Translating that into English, it means we're concerned about how statements fit together. We're not concerned about the meaning of the statements. That's why we're going to end up ultimately translating them out of natural language into a symbolic language. We don't really care about the meanings. Okay, so this is a critical point to make because some arguments, by our definition of validity that we've gotten already, could seem valid only because of their meanings, right? So, for example, suppose you have the premise. Oh, let's get a different writing instrument. John is 7 feet tall. Okay, John is 7 feet tall. Conclusion: John is at least 6 feet tall. Now, think back to the definition of validity that we've gotten thus far. The definition of validity we have says the truth of the premises must guarantee the truth of the conclusion. In other words, if the premises are true, then the conclusion has to be true. Okay? So let's subject this argument to that test. John is 7 feet tall. Let's assume that's true, even though it's very unlikely. Let's assume it's true. Does it follow necessarily that John is at least 6 feet tall? Well, yeah, it does. And so it seems like this argument would be valid. Okay, there are many other arguments like this that are valid because of the meaning of the terms involved. In this case, the understanding that 7 is greater than 6 causes this argument to be valid. What if I had said something like, John is a bachelor. Conclusion: John is an unmarried man. Okay. Well, if John really is a bachelor, then it follows out of necessity that John is an unmarried man. That's just the definition of what it is to be a bachelor. And therefore, it seems like that too would be a valid argument, but only because of the meanings of those terms. Okay? When we're doing TFL, we're not looking at arguments like that. In TFL, an argument like this one is invalid, right? So while this might be valid in a much broader scope, within TFL, it's not. Okay. Why? Well, because TFL is only looking at the structure of arguments, right? And the structure of this argument isn't doing enough, right? We need the meaning of the terms in order to see that this argument is valid. Okay. So, examples of arguments that are structurally valid or valid in virtue of their form alone, right? You can find 3 of them here, right? So number 1, if the grass is wet, then it is raining outside. The grass is wet. Conclusion, it is raining outside. Now we know that this kind of inference is faulty, right? Because if the grass is wet, it doesn't necessarily mean that it's raining outside, right? It could mean that you left your sprinkler on or anything else. Like there's a number of things that can make your grass wet, right? Nevertheless, this argument is valid. Remember, the test for validity is we assume the premises to be true. Does the conclusion have to follow, right? So let's assume premise one. If the grass is wet, then it is raining outside. And that's true. It's also true that the grass is wet. Does it then follow out of necessity that it's raining outside? Yes, it does. And notice that the validity of this argument does not depend on you understanding anything about the terms involved. It doesn't matter if you know anything about grass or rain or outside, right? None of that matters because this argument is valid by virtue of structure or form alone, right? Okay, so now that we kind of have an idea of what TFL is looking for, arguments that are valid by their structure, we can start to use it. The first step in using TFL is to learn how to translate natural language into formal language. Okay, so the first step in that is finding your atomic sentences, right? The sentences that can be, or the things that can be true that are in the smallest unit, right? So let's look at this first example, the grass is wet example, right? Let's look at premise one. If the grass is wet, then it is raining outside. That could be true or false, so that's a sentence. But notice that there are smaller sentences within this larger sentence. The grass is wet. That could be true or false, right? So that's a sentence. Next, it is raining outside. That's another sentence. Okay. Premise two, the grass is wet. That's its own sentence. And lastly, it is raining outside. That's another sentence. Now, in TFL, we want to assign capital letters to each of these. And we wanted to tell, our reader what our key is. So for this one, I'm going to say capital G stands for the grass is wet. The grass is wet. And I'm going to say R stands for it is raining outside. Oop. Okay. So these are all the sentence letters that we need. There aren't any others, right? We have the grass is wet. We have it is raining outside. And that's it for this argument. Let's look at number two. Sally had soup or salad for lunch. Sally did not have soup for lunch. Sally had salad for lunch. Okay, so this one's a bit more tricky. So it seems like premise one, Sally had soup or salad for lunch. That could be true or false, right? So that's a sentence. But can it be broken down into smaller sentences? Yes, it can be broken down into Sally had soup for lunch. And it can also be broken down into Sally had salad for lunch. They're just connected by or, right? Okay, so I'm going to need a sentence letter for both of those. I'm going to use O for Sally had soup for lunch. And I'm going to use A for Sally had salad for lunch. Okay, why aren't we including the or? Well, we're going to introduce ways to connect sentences together next, right? So you will need a different kind of symbol for that. Right now, we're just looking for the most basic claims that could be true or false. Okay, premise 2, Sally did not have soup for lunch. Well, that is just the same thing as O, but denied, right? We're just saying O is false. So in TFL, we don't give a new letter for that. We just say, okay, I'm saying something like not O, right? So we don't need a new sentence letter. What about the conclusion? Sally had salad for lunch. Well, that's just A, right? So we only need 2 for this one as well. Let's look at the next one. If Ali is going to the party, then Kim is not. Kim is going to the party, so Ali is not going to the party. Well, again, premise 1 could be true or false by itself, but it can also be broken down. Ali is going to the party, and Kim is not, right? Second, Kim is going to the party. And last, Ali is not going to the party. Now, in TFL, if you see not, or it is not the case, we don't want to incorporate that into a sentence letter. Okay, we want to be able to say, just like we did with O, that we can put a not in front of it. Okay, so let's start with A for Ali is going to the party. And let's do K. And let's say Kim is going to the party. Again, even though this says not here, I'm not going to incorporate that in my sentence letter. Why? Because I can always write not in front of this. Okay. So second premise, Kim is going to the party. Okay, that's just K. And then our conclusion, Ali is not going to the party. Well, that's just not A, right? So again, we're done with only 2 sentence letters. But sentence letters aren't enough to translate a sentence. We also have things, let's get rid of all of this, that are connecting these sentence letters together. We have if then here, we have an or here, we have nots, we've got another if then, right? More nots, right? These are things that we also need to capture. And the way we do that in TFL is with symbols. Symbols that represent what are called connectives. Okay. So now we're going to turn to looking at the connectives. We're going to start easy. So the first connective is called negation. Negation. Now, negation just flips the truth value of whatever it's applied to. Okay. So if you said Ali is going to the party, if you apply a negation to it, it now reads Ali is not going to the party. Or it is not the case that Ali is going to the party. We represent negation with this symbol. Right? That's negation in our system. Other systems use different things, but this is the symbol that our system uses. Okay? So you would just put this in front of any sentence letter. So in order to represent Ali is not going to the party, I would write not A. This now reads, it is not the case that Ali is going to the party. Okay? All right. So negation is the simplest one to understand. It just flips the truth value, right? Now, conjunction. Conjunction is also fairly easy. Conjunction we symbolize with an upwards caret, right? Like a triangle that's missing its base. Okay. Conjunction conjoins 2 things. It says both of these things are true. So you put it in between 2 different sentence letters, like this, A and B. That's how this would be read, A and B. A is true and B is true, okay? We call each side a conjunct, right? So a conjunction has two conjuncts. Okay, let's leave this example here. Okay, next up, we have disjunction. Disjunction is the same symbol, but upside down. So it looks like a big V. Okay. Again, we put it in between two sentence letters. Disjunction represents or. Okay. So this would be read A or B. Now, there's something we have to address with disjunction. In natural language, it's often assumed that or means one or the other, right? A is true or B is true, but not both. Within TFL, we use what is called inclusive or. Inclusive or says that if either side is true, then the whole expression is true. But it's also true if both sides are true. So in this case, A or B would be true if A and B are both true at the same time. So the way we use or in modern logic is inclusive. It's inclusive. We're going to include those cases in which both sides are true. Now, each side of a disjunction is called a disjunct, right? So conjunctions have conjuncts, disjunctions have disjuncts. Okay, next up is the conditional. The conditional is how we represent if then, and we use an arrow. Again, in other systems for each of these symbols, they might use a different symbol, but this is what we're going to be using. It, once again, goes between two different sentence letters. Okay, so the way this would be read is if A, then B. If A, then B. Right, so in English, negation is it is not the case. It is not the case that. Conjunction reads and. Disjunction reads or. Conditional reads if, then. Okay. Now, how a conditional ends up working out in terms of truth values, we're going to have to wait until the next video. It gets a bit more complicated than negation, conjunction, and disjunction. Next, we have a biconditional. A biconditional is just like a conditional that works both ways. It's a much stronger relationship. We use the biconditional to represent the phrase if and only if. In philosophy or in logic, we sometimes use IFF instead of writing out the full if and only if. It's like if, but with an extra F because it's much stronger. We represent this with a double-sided arrow. Okay, so it would look like this. Reading A if and only if B. Okay. Now, a biconditional is much stronger than a conditional. If a biconditional is true, that means both sides guarantee each other. In other words, if the left side of it is true, the right side of it has to be true. And if the right side of it is true, the left side of it has to be true. So you can see it's a very strong relationship. A and B are ultimately both going to be true, or they're both going to be false. Right? Okay. So now that we know what our connectives are, these are the only ones we have within this system. We can return back to our examples and finish the translating. So in example 1, we have an if, then. For premise 2, we don't have any connectives at all. We just have the grass is wet. And for the conclusion, again, we don't have any connectives at all. So it looks like we really only need one, and it's going to be a conditional. By the way, the anatomy of a conditional is pretty important. The left side here is called an antecedent. Ante meaning before, right? So antecedent. The right side is called a consequent. Consequent. All right, so let's translate what we have. We've already given a key with our sentence letters here. So we now know if G, then R. So if G, then R. Okay? Premise 2 says G. And our conclusion says R. And this is fully translated, right? We've gotten rid of every bit of natural language. Now you can see why this argument is valid because of its structure alone. We don't know anything about G and R, right? If you just showed this argument without the key to someone, they would have no idea what you're talking about where G and R are concerned. The meanings of those terms would be absent for them. Nevertheless, you should be able to look at this argument and know that it's valid regardless. If G, then R, G, therefore R. Yeah, that's one of the most basic valid argument forms, right? This has to be valid, even if you don't know what those things mean. Okay, next problem here. Sally had soup or salad for lunch. Well, now we know that we can symbolize this or with this large V, right? So we're going to say Sally had soup or Sally had salad for lunch. Okay, that's premise 1. O or A. Premise 2 is not just a sentence letter. We have the word not here. So we're going to say not O. The conclusion then is just going to be A. Right? We have no connective here at all. Okay, so O or A, it's not the case that O, therefore it has to be the case that A. Once again, this is a valid elementary argument form. Call this disjunctive syllogism. You'll learn more about that soon. Okay, let's look at problem 3 now. Problem 3 again has an if-then, but it's not just an if-then, it also has a negation. So this is going to be A, arrow, negation, K. Okay, this reads, if Ali is going to the party, then it is not the case that Kim is going to the party. And that's exactly what we have, more or less, in natural language, right? So that is how we would translate premise 1. Premise 2 just says Kim is going to the party. That's one of our sentence letters. That's just K. Okay? All right, and then our conclusion, Ali is not going to the party. In other words, it is not the case that Ali is going to the party. So we're going to use the negation symbol applied to A. Okay? And once again, this is a valid argument form. These arguments are valid because of their structure, not because of the meaning of their terms. Okay, so now that you know how to translate natural language into symbols, we're going to move on from natural language. We're done with natural language. So for now on, we're just going to be using these symbols. We're going to be using capital letters to represent natural language sentences, and we're going to be using these symbols for your connectives to join them together. Okay? Eventually, we're going to have complicated looking sentences, right? So now that you have your connectives here, you can build many different sentences that can be true or false. You can have as many connectives in a sentence as you want. So for example, I could say A and B, and perhaps I want to say, well, A and B or C. How would I do that? Well, I would need another sign for or here and C. But that's not enough, because if I leave it like this, it's ambiguous. This could be read as A and B or C. Or it could be read A and B or C, which is slightly different. So in order to make it clear, we have to use parentheses. Since I wanted to say A and B or C, I have to use parentheses here. This reads A and B or C. I could have written it like this: A and B or C, right? These two things say totally different things, right? So it's very important that you keep your parentheses straight here to indicate what you mean, right? Okay, we can keep adding more, right? I could say A and B or C if and only if, let's say, D and E, okay? Now, best practice is to use parentheses whenever you can, right? So maybe I'd put parentheses here to show that these are separate, right? I could add a negation sign to one of these things. I could say A and B or C if and only if it's not the case that D and E. Okay? So we can build more and more complicated sentences. Now, negations and parentheses. There's another important little quirk here. This means it's not the case that D and E. The negation, then, is applying to the conjunction between D and E. We are saying it is not the case that D and E. Okay? Now, if we have this instead, we're saying not D and E, which means D is false and E is not, right? We could have this, D and not E. We could have not D and not E. These all mean different things, right? Perhaps you think that these two examples ought to say the same thing. This is a common mistake because you're used to, in mathematics, distributing, right? Negations don't really distribute like that. Here's why. This bottom example, it's not the case that D and E could be true if D is true and E is false, right? Why? Well, because and, right, our conjunction here, is true only if both sides are true. And this is telling us that the conjunction is false. So there's many different ways for this conjunction to be false. D could be true while E is false. D could be false while E is true. Maybe D and E are both false. There's 3 different ways in which that conjunction could be false. Whereas up here, this is telling us outright, no, D is false and E is false. That's the only option, right? So they do not say the same thing, even if you might think they do. Right. Okay, so now that you know what the symbols are and sort of what they mean within a natural language context, we can now start talking about their truth values, right? What exactly they're doing when it comes to manipulating truth. For that, we're going to need another video, all right? So I'll see you there.